Today, I've got an article from the New York Times that I want to talk about, both good and bad. So let's take a look at this article. I first saw it on Twitter, which I think is important because on Twitter it says, flushing the toilet may fling coronavirus aerosols all over. So this is clearly one of those headlines that is intended to make you go, oh no, and then read the whole article. So as we probably already know, I hate that. I don't think headlines should work that way. I like things to be informative and not interesting, negating actual information. So that's a problem. The underneath piece here says, a new study shows how turbulence from a toilet bowl can create a large plume that is potentially infectious to a bathroom's next visitor. So you'll notice that this includes the words can create and potentially infectious. So as you can see, I am already going to have some trouble with this. Now, this isn't my least favorite article of all time. In fact, the New York Times mostly does a very good job with their articles. And in this particular instance, the person who put this together did indeed cite mostly scientific sources. Like, in fact, they are generally, almost all of these links are to articles of some kind that are manuscripts, that are peer-reviewed, that are in journals. So I think that's great that if you're going to do that, that's what you should do. Here's my problem, though, with it being in a newspaper and with it being put together by a person who, is a science editor, but not exactly a person in the field in these areas, at least as far as I know. So let me see. This person definitely does a variety of different kinds of articles. So do I technically know her background? No, but based on the way this is written, that is my take. And here's the reason why. Because she puts together a lot of scientific things in a way that I would not as a scientist. And I want to go through it and show you why. So there's two different major things sort of going on with coronavirus articles. We've got articles in which we are testing out real things in real time, in real situations. We are counting the number of virus particles, or we are looking at patients, or we are examining tissues. And then there's modeling, which is where we take some data that exists, put it into a larger scale model of some kind, and turn it into what could happen based on various circumstances. So briefly, there's always problems with modeling. In fact, it is said somewhere, I heard this on a podcast, so I'll have to find the right attribution for it, that all models are wrong, but some are useful. And that's definitely the way modeling works. It's important to understand what kind of model you're using, how it works together, and what information it provides, but then be able to critically evaluate how to apply that to an actual situation. And this article does a combination of modeling and experimentation in ways that make me think the intent is to scare people more than the intent is to inform people. And I think that's where the problem comes in. I think we should be informing people more than scaring them. So let me talk you through this article. All right. So it starts again with the scary thing, more behavior to be hyper aware of in order to prevent coronavirus transmission, what you do after you use the toilet. Okay. Flushing a toilet can generate a cloud of aerosol droplets. This is not unknown. And I think it's interesting that we call this a new concept or a new art. Like there is a new article. It's the physics of fluids. And in this article on the physics of fluids, which I believe I do also have, there we go. Physics of fluids. Can toilet promote virus transmission from a fluid dynamics perspective? All they're doing in this article is saying, will this flushing induce turbulent flow expel aerosol particles containing virus out of the bowl? So this requires two things. One, do particles go flying? Two, do those particles contain virus? And this is done in a simulation in which it says that, these particles reach above the toilet seat, leading to large scale spread. But of what? So when we read through this article, again, they use toilets, but they do modeling. So it's a little bit hard to tell exactly how you're going to back relate it to your toilet. It does the mathematical formulation where you explain what's happening in different ways. It uses a lot of math, which from my last video, equations work well in other places. In biology, they're usually only one tiny part of it. And then my favorite part, assumptions. So they go through and say that all of this stuff remains the same. So expect feces are ignored. So we're just looking at water flying. The size of particles remain constant. The temperature is assumed to be 20 degrees C. I love physicists because they like to keep everything exact. If you've ever heard that, like, physics can always figure out problems, they just turn the cow into a square. Yeah, that's precisely what they do. And then they determine what's going on. So these are all models. They did not actually throw a virus into a toilet and measure the particles coming out. So this is all assumptions based on modeling. So that's item 1. Now, early on in this article, it does say it remains unknown whether these toilets are a common point of transmission of the virus. And I will note that in SARS, it became very apparent very fast that toilets were indeed spreading the virus because of the way certain outbreaks happened. And at this point, I am unaware of any outbreaks linked to toilets related to COVID-19. I've read a number of articles related to that. So this might happen, but it's hard to tell. The other thing is that this assumes that we have active infectable virus particles in the toilet. And that is the next thing that this article goes into. It says the coronavirus is most at home in the lungs and the upper respiratory tract, but it can dock to cell receptors in the small intestine. And if you look at that article, and so this becomes the problem, is that for every citation that is made here, I feel you have to go check out the article to understand the details. And that patients have reported other symptoms. Other symptoms, definitely a thing. But as I've noted before, a lot of those seem to be caused by extraneous functions, not necessarily the virus attaching to those areas. In some case it does. It was shown in the liver, in the spleen, but in the intestines, not as much, and especially in those autopsies. And although we have found viral particles is in RNA in fecal matter, there doesn't seem to be a lot of infectious fecal matter. So, and it says it right here, although experiments in the lab have suggested the material may be less likely to be infectious compared with virus that is coughed out. And in fact, pretty much not hardly infectious at all. I would say there are bigger problems with bathrooms, let's put it that way. And so then it goes through the computer simulation about the vortices. It involves a quote of somebody who says, "It's very alarming," who is a co-author on the study. These fluid dynamics people sometimes tend to be a little bit more like, "Oh no, this is bad." And it's like, I don't understand. We've known how toilets work for a while now. So this doesn't feel new to me, and I'm not sure why we're suddenly alarmed. Like I said, SARS 100% spread that way. There's a whole study of like a building, I think it's in Singapore, in which that happened. It's really interesting. Now, here's the thing that I do think is key, is that bathrooms are poorly ventilated spaces. So if somebody who has viruses in it, they're also breathing in this poorly ventilated space. And the surfaces are high touch, which means everybody who goes in there touches them multiple times. So I think that's an inherent problem. And it does show that viral RNA was found in shared toilet areas at a hospital in Wuhan. Although I will note that when I've been reading the articles that backtrack about places that are not hospitals, a lot of times these numbers are smaller. It's a little hard to tell. Although in China, there was that one shopping mall that got a lot of people sick, and no one's really sure exactly how that happened. So I find that interesting. Now, I mean, here's a key, something you can do. If your toilet has a lid, close the lid before you flush and things will not go flying. That's always a good idea. It says, you should wash your hands. So that's good. Remind people to always wash your hands when you're doing things. If you're in a bathroom, hey, and you're wearing a mask, this is a good time to keep it on, because then not as many particles are going to get into you. Okay, so My TLDR on this article, though, is essentially, should we suddenly be more worried about bathrooms because of toilet flushing? In the case of COVID-19, I don't think so. I don't think toilet flushing is making that big a difference. There doesn't seem to be a lot of transmission coming from fecal matter, even though it's come up a few times. Any of the papers I've read don't discuss that. There doesn't seem to be any outbreaks linked to this, which there probably would have been if that was possible, if it was common. Do I think that small, poorly ventilated bathrooms are a place where viral particles could be concentrated if a person who has the virus in some way or is passing it would be in for that length of time? Yes, definitely. You should be careful and not be in for very long and move yourself out and clean everything, because why not? Do I think the New York Times should have written an article titled this, which is now going to make a lot of people panic? No, because to even get through the basics of this article, you have to read 4 different journal articles in 4 different fields just to get a sense of the sort of reality of it, have an understanding of how modeling works, and have a basic understanding of viral transmission. And in this case, even though we're still working on that, I read enough to be pretty convinced that this is not the most likely form. So if you're reading this article, you have now seen what I think about it, and hopefully be a little bit less panicked for the future. Also, New York Times, do better with your headlines. Thanks.